Hi, Scott Kitterman, among other things. I'm a Ubuntu developer. I'm going to talk about Ubuntu Netbook. Hopefully the microphone, okay, I got to stay a little closer to the mic than I thought. Is that better?
Yeah.
Okay. Go back to the Jonah's first day presentation. We had the slide of all the Ubuntus. Well, this is a new one for this site called Ubuntu Netbook. And I'm going to do some slides and do a little bit of demo depending on how well it works and how much time I have. Slides in part with the backup for if the netbook would work on the projector. What we did is, there is no netbook KDE officially yet. We worked with KDE upstream, we took the development work, brought it back a cycle for them into our KDE 4.3, and so what we have here is a pretty stable but subset of what they want to do for KDE 4.4 that we'll get in Lucid. And they've been supportive of that, helpful. When people on blog posts have said, oh, look at these Ubuntu crazy people again, they're doing backporting stuff. No, we're working with them, it's okay. And so that was one piece of this. The other piece was, Canonical in other Ubuntus is already doing a fair amount of work on making the infrastructure piece work on hardware. And so there's a few things we had to add in, but basically it was just putting the pieces together, kind of what packagers like to do. So we're calling this Tech Preview, in large part because it's not Upstream's finished vision of netbooks, but it's a long ways there. You can see it. I say it's not for grandma, maybe for your wife and kids. My wife and both of the daughters that are over 10 use it regularly, and the two teenagers, I just handed it to them and said, here. They had a couple of questions and they just used it. So it's not bad. It seemed to go pretty well this last cycle. We laid out a plan that was pretty conservative. We set okay, if we can only do this, if we can get an ISO and kind of produce like a miniature desktop version that works, that would be enough to call it a win. We were done with that by Alpha 3, and then we did the Plasma Netbook stuff that we're going to see today, and it all worked out pretty well, drama-free. I'm glad how it went. Community did a lot of this work, but anytime we had a hard spot and needed some help, there were Canonical people that were glad to help out and keep us moving along to getting where we needed to get. And from my perspective, this is kind of a risk reduction effort for what we're about to start now. It's a good chance for Upstream to get some early user feedback on where they're going. We've got the infrastructure in place. This will be with KDE 4.4, and we'll just move on into it. It's all there. And so it's been a good start. I'm going to show you Search and Launch, which is what was up here to begin with. Talk about the news scraper a little bit, which is sort of the different. This is the desktop for Ubuntu Netbook. If you go back to when KDE 4 started, a lot of KDE 4 was around the idea of building the space to be able to radically reinvent what the free desktop looked like. And I think in a lot of respects, this netbook form is kind of the first evidence of that and how things might be different. So I'll more about that later. You saw when I was switching the apps, we're very dependent on compositing here, but most of the hardware we're targeting, the Intel Atom devices support it. Another reason we're a tech preview is if we don't have compositing on, there's some things that don't work real well. But that will be fixed in 4.4 and it will work better. And I'll talk more about how the different pieces of it work when I'm doing the live demo. There's plenty of information out there. One thing that's nice about trying to understand the design and what's behind it is it wasn't just a bunch of people sitting down and starting slinging code. There is an actual design and concepts and rationale behind what's going on. The first link there talks about the just all work in the Ubuntu Netbook, and then the next two talk about Upstream. There's a detailed design paper and then a presentation on what they were trying to do when they started this. We're also building for ARM, and they work. I don't have any ARM hardware, so I can't tell you how well they work. And it depends on exactly what you have. I've heard good and bad reports, but it's pretty cool that it works. And it's a good step for being ready for the next cycle as the ARM hardware becomes more capable. And then this is what trunk looks like today. It's a little different than what I have, and I'll come back to this in a minute. So the panel here is a little different than a typical one for a desktop. You don't have any icons in there for your applications to switch. You're really dependent on this kind of application switching. And it works real well. I actually start to miss it on my desktop when I don't have the whole top to get to it. The other thing is, this is your also interact with the applications. If you want to close out an application, that X is right there. No, I don't want to do that right now. But, and then in the production, when we get into this for real, we're going to also take that top ribbon off of each application, because the panel will do what you need what you mostly need that for. And the idea is working really hard to preserve the vertical real estate that people have to do actual work. So this is the search and application launcher. It works pretty much the way you would guess it would. And you have a favorites bar up here where you can promote different things up there that you use a lot, so it's easy to get to them and just dive down into the categories. And then we have this other thing called the newspaper, which is a little more radical. And all this is a bunch of widgets. And the thing that is really, where the word newspaper comes from, is this is very long, even though you see a little bit of it at a time. And so you can scroll up and scroll down and have a widget list that's much bigger than the actual screen. And so once again, this is trying to work with what we have in terms of real estate to make people able to do what they want to do most effectively. So I'm going to go back to the presentation now for a moment and then talk a little bit about what's upstream. So this looks almost like what you saw. The two big differences are that the favorites bar at the top, it doesn't have ends anymore. It goes across the whole page. And there's a lot of work going into this. And if you have more than fit, then you have arrows on each end. And you can grab it, you can drag it, you can throw it. It's kinetic. The idea being to get a natural, if you have a long list, let me get to it. And then the search bar is now embedded in the middle of the search and launch. And a really nice touch, I think, is then when you come into this, the search bar gets default focus. So if you switch to search and launch, you can just start typing, and it, bang, you get your application, click, and you're off and running. And so this is more like what you're going to see in KDE 4.4. I think it's really well thought through, and I'd encourage people to try it. Upstream's asked us for feedback, wishlist bugs against Plasma Netbook, and bugs.kde.org. If you don't remember that, feel free to talk to me because they want to understand how people use this, how it could be better. This is also interesting, I think, for the Ubuntu community, Ubuntu, in that today there is no other KDE netbook distro in the world. If you want to do KDE on netbooks, this is the only place to come. And so 6 months from now, when everybody has it, well, we've been doing this and we know how to do it, and we should be in pretty good shape. I'm pretty happy with that. And I may have 3 minutes for questions if anybody has any.
It looks a lot like your Ubuntu Netbook Remix anyway. Like, was that a design,
I've never seen a Ubuntu Netbook Remix.
Oh, we can fix that.
No, I mean, this is, the people who did this took a look at the landscape, thought about it, and said, what's not right, how can we do better, how can we do it better? And they went and produced this. And from what I know about it, that sounds kind of like what the UNR folks did. And it's perhaps interesting that maybe they came to some similar conclusions.
Can you talk a bit about how the web or the browser are integrated into the experience, if at all?
Right. Well, a lot of the widgets that I showed there are network enabled. And so that's one of the primary ways this is different, because in a normal desktop, you don't have so much screen real estate for widgets and you never see it, so nobody really uses it. We bring the widgets to more centralized in terms of how the user experiences the system. The web browser we use right now is no different than it is on a desktop. One of the things we're going to do in this cycle is look at our application selection and look for things that would work better, be more suitable for this form factor. Right now, from an application level, there isn't a lot of differentiation. And this is something that's going to evolve over time. For example, not for Lucid, but for Lucid Plus 1, in KDE, email will start being in Akonadi. And then email starts to feel more like a service and less like an application. And there's already very netbook-oriented, lightweight Plasma email clients, front ends in development, so that when we get to that, we'll have a really cool email experience. I don't know if people are doing that with a web browser per se, and that's part of the work we have to do. Okay, thank you.
Thanks, Scott.
Great, it works.
So, it's good to be here. I don't know how many people out there I've actually met so far. I don't think it's a huge number. So I'll introduce myself quickly. My name's Dave Martin. I've worked for ARM for a few years now. And for the last year or so, I've been working to help liaise with the Ubuntu on ARM effort, the work Canonical and the community are doing. So this talk, because most of you are mostly familiar with x86 land and the other devices that have been out there for a longer period of time, this is just a lightning tour of what ARM is, what it's about, and what Ubuntu on ARM is, where it's currently got to, and where we're hoping to see it go in the near future. So, quickly, what is ARM? Who is ARM? ARM is the world's leading semiconductor IP company, and what people often quote is that we're a chip maker, but what that means is that we're actually not a chip maker. We develop and we license chip designs, but and those are across a range of things, especially microprocessors, and that's where our tradition comes from, but also bus fabric and peripherals, graphics IP, and all sorts of things that goes around that, and tools and other stuff. But at the end of the day, in order to turn that into something real, ARM needs customers who are hardware companies who make that happen. And these are people such as Marvell and Freescale, who are already cooperating for official support in Ubuntu, and also many others, and we're hoping to see more of those on the Ubuntu wagon in the near future. Some of you might be wondering how significant all this is. Well, I still have difficulty getting my head around the actual numbers. So far, about 15 billion ARM processors have been shipped, apparently. That's over 2 for every person on the planet on average. So, and at current trends, about 1 billion more are being shipped every quarter. So that's a lot of gadgets. And although, okay, some devices have more than one ARM processor in, and a lot of those are deeply embedded things. But even if Ubuntu is running on a pretty small proportion of those, that's quite a lot of Ubuntu users potentially, so it could be very interesting. Just to give people a very quick idea, ARM is not a single processor, it's a processor architecture which has its own history, and this shows a progression that's been going on over recent years. With a trend towards increasing features, increasing performance. And on the right-hand side, now in the newest version of the architecture, we produce devices across the whole performance spectrum, so the software can largely interoperate across those implementations. but you have devices which are suitable for embedded, as well as the devices which are most interesting for Ubuntu at the top right there, Cortex-A8, Cortex-A9, and third-party implementations of the architecture, which are very much applications processors with all the features you've come to expect as software developers: 32-bit virtual memory, protection. Now we have a established hardware floating point architecture, SIMD acceleration, and all the things you've come to know and love, or not, as the case may be, as you hack on other architectures. So that's okay. ARM's great. So, but why am I here? Ubuntu is actually important to us because historically Debian had done quite a bit of work to enable ARM support for their own hacking joy that they like to do. Ubuntu derives from Debian, so it already had a big step up in terms of supporting ARM. And at the present time, Ubuntu is a big set of good software, highly portable software, so it's potentially a good fit for working on new architectures, including ARM. It's obviously actively maintained and developed by, well, you guys, and a lot more besides who aren't here today. And you have an important role in the open source ecosystem, so good stuff that goes on here for ARM has an impact elsewhere as well. And you're very user orientated, so the place where ARM devices have traditionally done well is in flashy gadgets and fun devices that people like to use. So Ubuntu's clear, user-friendly interfaces and so on, potentially a very good fit for that. Quick summary now. Fortunately, I don't have to explain the jargon here to anyone. Well, not the Ubuntu jargon anyway. Just to explain where we are today. The Karmic release which we've just made is the second release to officially support ARM. So there was support in Jaunty, including support for the Freescale IMX51 implementation. Karmic brings things a little more up to date. So that's built against the ARM v6 architecture, which is a more modern architecture from what you see in the Debian legacy support. And it's also the first large-scale Linux distro, I think, to natively build for the modern floating point architecture in ARM land. And also in that release we added support for the Marvell Dove platform, so this is another hardware implementation. For the coming release, we'd like to aim to bring things right up to date with support for ARM v7, modern floating point, and the Thumb2 instruction set, which provide code size benefits, but should still get performance that's just as good. We're hoping to add more platforms during this cycle, and it should provide a stable, forwards-compatible baseline for Ubuntu to evolve in the future. And one other thing which we'd like to look at is to validate multi-core support for processors including Cortex-A9, which is going to be ARM's first multi-core processor supporting the v7 architecture, and which we're going to start seeing in hardware in that cycle. What kind of devices are we going to see with this technology in? One thing to highlight is that a lot of these things are not going to be traditional PCs or even traditional laptops. You may get laptop-like things like, for example, this NetTops type device. That's made by a company called Pegtron, based on Freescale's technology. But also other things, gadgets, and more innovative designs that people are currently trying to come up with. So these are going to be things which are very portable, typically long battery life, wireless network, so either Wi-Fi or 3G broadband or Bluetooth and so on. And there's going to be an opportunity for lots of innovative UI work. So most of these devices, or a lot of them, will have touch screen, may have multi-touch capability. Most of this hardware has 3D graphics capabilities, so there's lots of possibilities there. A lot of devices will have built-in cameras, which has already become widespread in phones, of course. And there also may be GPS location services. motion and gesture sensing, again interesting for UIs. And because we're operating at a low power point, these devices are generally going to be silent in operation. Well, when you want them to be anyway. So, lots of opportunities, some challenges as well, and a few of the key goals that we're going to be focusing on in the common cycle. The points summarised here. So, there's lots of work going on to work towards a more unified boot process to make installation and upgrading and just managing a distribution on ARM platforms more straightforward. And also, we want to improve the unlocking of the capabilities, quite sophisticated capabilities now, which these hardware platforms support. So these are things around power management, use of hardware, media decode acceleration, which enables you, for example, to play video with quite a low power cost, and also to get the best out of integrated graphics. A lot of graphics hardware that we see in these platforms is based around OpenGLES2, and it would be great to see better use being made of that and better integration in the future. But all these things should enable a lot of innovative new things to go on, and hopefully should enable Ubuntu and ARM to stand out. So that was a very quick overview. Should check what the time is. Okay. Got through that more quickly than I thought. That was quite a dense presentation. So if anyone wants to ask questions now, we can do. There's also a blueprint scheduled that will take place on Thursday, when we'll go into some of these points in a bit more depth and highlight some things that developers want to be bearing in mind to get the best out of this technology. And also, there are discussions related to ARM going on throughout the week, particularly in the mobile track, so watch the schedule. And actually, before we move on to questions, there's one other thing that I was going to say, which is just a big thank you to the Canonical Mobile team and everyone in Ubuntu who's been involved in this, as well as I know there's a few people from the hardware companies here today as well. So can we have a round of applause for everyone who's helped make this possible? Question then.
When can I buy a laptop running ARM devices, do you think?
Yeah, I get that question a lot. At the moment, there's nothing which is on the market yet. We're seeing a number of devices going through the pipeline. It's possible David may be going to give an update on something he knows. I think we are expecting to see things that people can actually start to buy into next year. Don't know if you want to comment further on that. It's available now. Okay. Cool. I shall have to get one.
I just wanted to point out one key thing. This presentation was brought to you on Ubuntu on ARM. It's got the device underneath, and that's what's actually displaying all of this. So it's running.
You stole my thunder. I was going to surprise them with this when I walked away.
Couldn't resist. So there it is, guys. The teams here pulled this all together, and the OEM team did a lot of work on this particular thing. Pretty excited about it.
Just in case you don't believe it. And the great part is that didn't happen while I was giving my presentation.
Yeah, George. I got one question regarding the OpenGL hardware you talked about. Is this IP you're developing inside ARM, or are you buying that stuff from other vendors?
So there are lots of vendors providing hardware IP. Some people have their own. ARM are also developing their own hardware IP around graphics in-house. So, but there's lots of things in that ecosystem. However, OpenGLES2 support is quite typical because a lot of the hardware is targeted at high-end smartphones. So I don't know who's seen the Nokia N900 device, but that, for example, has some quite nice 3D graphics in it, and that's enabled by OpenGLES.
Unfortunately, I didn't attend the MAMO Summit, so I didn't get my free one for attending that.
Which leads me to the next question. How can you kind of control that there are actually going to be drivers from the start for, well, Linux and Ubuntu specifically, so that it's not like another pulse book? Yeah, I said it.
Well, basically that involves collaboration between the hardware companies and the open source community, and I know the mobile team are working closely with those guys to help make sure that those things are in place. It's obviously in those companies' direct interest to make sure that we have good graphics support, because Ubuntu and Linux is one of their ways of selling the platform.
Right, so one thing that interests me a lot is that ARM provides great features for hardware acceleration for video playback, for example, but I guess it's very hard to integrate this into something like Ubuntu, which has layers and layers of GStreamer, etc. So is there actually any work going on to integrate these kind of hardware support into GStreamer?
Well, that's, I think, the preferred architecture, and we've certainly seen implementations where a GStreamer backend has been implemented that uses the hardware acceleration. And basing high-level software on those kind of frameworks rather than manual hacks is the way to get that flexibility. So I think I'm out of time. Thank you all for listening, and you'll see me around.
Wow, that's all yours. Hello, I'm going to try something that I haven't tried in front of a conference before for a while now. It's actually interpretive dance.
Let me just get Bryce ready before.
Okay. Wow.
Bryce!
Thank you so much. Okay, so hi, I'm here to talk. My name is Jonathan Lang. I work on the Launchpad team at Canonical, and I'm here to talk about the Launchpad API system that we have. The Launchpad API system is a way that you can remotely interact with Launchpad programmatically, and it's something we've had around for a while now. We added it a while back because there are a few things that people wanted to do with Launchpad. They wanted to get at their data, they wanted to implement policy for their own upstream projects in a way that Launchpad can't across all projects, and they just wanted to do things that Launchpad doesn't do yet. So we thought, okay, let's provide a structured system of RESTful APIs. Does anyone here know what REST is? Or hand way up, I can't see. No. Yeah, if you know, yeah. Okay, there's about half of you. REST is like an HTTP-based API. So rather than like having XML RPC methods we call functions, you think of things in terms of resources, and you use HTTP methods like GET and POST to talk to the REST API. Launchpad uses REST, the RESTful system, and uses JSON objects for transferring the data. So it's a very language-neutral API. This API was mostly implemented for us on Launchpad by the guy who wrote Beautiful Soup, the screen scraping tool, which is great because now no one's screen scraping Launchpad or anything like that. Anyway, what I want to do is I want to show you an example of Launchpad lib, which is the Python-specific version of the API, so that you can start hacking with it, so you can start using it to do your own cool things with Launchpad. I'm just going to have 3 parts in the talk very quickly. I'm going to show the example. I'm going to talk about some gotchas that you have when using the API, because I get asked questions about this a lot on Launchpad, and then I'm going to point you to the future direction of where you can go. So, the example. Hey, all of my carefully placed windows have been... Okay. So I wrote this, I'm rather than cutting this right in front of you now, I'm going to use one I prepared earlier. This is a basic, can you read that? Sorry. Okay, this is a basic Python script. It does nothing. If you run this Python script, It does nothing. This is called test-driven development. Bug-free. Yes, it was in the spec. The next stage of writing a Launchpad API script, beyond just the basic version of Python, is 3 cheers for Emacs. You know, they're almost... Okay. So what you do is you import Launchpad lib. From Launchpad lib you get the core Launchpad object, and you get some reference to the core service. We're going to be running this against the Launchpad staging server because I don't want to be messing around with live production data. This is a great way of testing scripts if you haven't got a local Launchpad development environment. More on that later. Every script kind of has an application name. This is so to identify the application, largely for authentication and credentials. Has a cache where all of the objects are stored, and it points to a service read. Then I have this script, very, very simple. It just gets the Launchpad object, logs you in with all of that data, and then prints the title of bug number 1. That's what it's supposed to do. So we run the script, and what happens now is you get prompted to open your browser. Your browser is like a trusted client, and you see here that Launchpad is now prompting you to say, hey, what level of access are you going to give this application? Because I only tested it with change anything, I'm going to test it with change anything here. You also see the URL is staging. Okay, then you go back to your application, hit enter, and it works. Microsoft has majority market share. Run it again, and the truth still sadly stands. Third stage, very basic script. That is hello world in Launchpad lib. Third step, I'm going to give you an application. Wow. I'm going to give you an application. So this application does something a little bit more complicated. What it does is it's starting to print some interesting statistics about bugs. This will take a pillar name, we'll skip over that, and then a reporter, specify like a project and a username, and it'll tell you how many bugs they've had fixed in that project. Or at least that's the theory. Okay, that works. So let's see okay, so how many bugs have I ever had fixed in Ubuntu? What do you think? 1. What about someone else? $172 bucks. That's okay. It's very well done. Okay, well, I don't like this because I also have bugs in Ubuntu and I'm not as successful in getting this done. So maybe what I want is to get a measure of percentage, because maybe NPT files more bugs than I do. I don't know. So, next stage. And this is my final version. Isn't Bazaar great? It's great. Like, I was never thought of using Bazaar as a slideshow before. Okay, so this script, same thing. It has this length thing, which is a workaround for a bug. William Grant pointed me out to this bug, to the workaround, and someday someone will provide a patch for that. One of you, perhaps. I'll walk you through the script. It logs in. It gets an object representing the first argument, the pillar name. We kind of use, that's like the first thing in the URL after launchpad.net. It then gets you an object representing the person, the reporter. Pretty simple. It then searches the bug tasks on the pillar, so in this case Ubuntu. It searches for all the bug tasks, things that affect Ubuntu, and are marked fix released. Then it searches and reported by the reporter. Then it does the same thing, but with all of the statuses. Because by default it searches for open bugs, so I had to specify them all one after the other. Then I calculate a percentage using some very sophisticated mathematics, and print out a number. That's what I do. Now I bet you're wondering, like, how did I figure out to call search tasks, and how did I figure out all of this pillar stuff? I know that's kind of what you're thinking. So, because I know what you're thinking, I decided to give you the answer, which is the Launchpad API docs, which are these are reference docs. As you can see, they're written as REST API docs. They're not Python API docs, they're REST API docs. It's a bit confusing at times, but once you get the hang of the mapping, it's pretty straightforward. There are some examples on the help wiki, help.launchpad.net/API, and I've started improving the docs now, so it's all good. Running the script, will it work? Okay, what's my success rate at getting bugs on Ubuntu fixed? Okay, that's not too bad. It takes 47%. That's okay. So he's better than me. But what about Launchpad? Like, I've been working on Launchpad for ages now. I get to fix my own bugs. I'm a coder. Like, I should be able to have a higher rating than Matthew Paul Thomas. Okay, that's pretty good. Surely someone can beat him. Okay, that is my example done. Okay, very quick stroll through the gotchas. There are bugs in Launchpad lib and laser.restful, which is the system it's built with. So, I'm sorry. There are docs, as I mentioned before, they're mostly written in terms of REST rather than Python. They're also auto-generated from the exposed APIs, which means that the computer sometimes has stupid text. We're working on this, and basically the way to improve this is when you have a question, you edit the wiki and you give your answer there. Error messages are often pretty low-level and confusing. There is a workaround for this, which I've now added to the wiki. The other thing is when you're writing API programs, often it's very tempting to have a list that's like a for loop that goes for thing in list of objects, do this remote request. This is really slow because it's a round trip every time. So you don't want to do this 1 potato, 2 potato, 3 potato thing. If you've got an idea for a list-based operation, you should probably add that to the API itself in Launchpad, or there are some ideas we have about how to solve the problem at a general level, which we're thinking about. Not all of the API is exposed. Some of it is garbed, and not everything that's in Launchpad is currently exposed to the API. This is mostly a matter of getting around to it, and it's a very easy thing to add a patch to do. And I'll be running a session later on in UDS, getting you set up with a Launchpad development environment and showing you how to expose an API in a patch. It's really easy. And no one knows how to unit test programs like this yet, short of doing what I just did. The Launchpad lib API is now currently being used by other things. It is the way the Ubuntu branch imports interact with Launchpad. They're an external service that use the API to set everything up. BugHugger, I believe, uses the API extensively, as does Quickly, which is great. Here's some stuff that you can read if you want to learn more about the API. I know some stuff, but many people here know more than I do, so the best thing to do is to talk on mailing list or IRC. 4 minutes for questions. 4 minutes for questions, that is exactly what I wanted. Please.
Like, how would you envision the change, like the exposing the API to, like, how would you envision it would help bugs and like triage and all that? Like, would you like if there was like desktop applications that listed the bugs in a certain way and give out stats, or is that the reason why you did it?
So there are applications that do. So BugHugger is an application designed to help with bug triage, particularly focusing on some particular Ubuntu needs. We expose the API basically, for many reasons, the ones I listed earlier, to help people get at their data, to see people do cool things that we aren't doing yet, and the things we never thought of. That's exactly it. It's a good test bed for stuff that can go into Launchpad later. Marcus.
How's the caching in that?
It's storing files on disk. So the files it downloads are JSON, and I believe it just stores the JSON files on disk.
But like if I do the same request twice?
That I don't know. I would hope that there's like a last mod, like it respects the last modified header or something. but I don't know that for sure. Good. If it does, then that's great. Yeah.
Okay, time. Thank you.
Thank you very much. If I unplug this, will my computer crash? If I unplug this, will my computer crash?
That's Bryce. Woo. While he's setting up, Dustin's going to do a two-part plenary. Intro to KVM is going to be right now, and then part 2 with upstream KVM will be on Thursday. So as soon as you're ready there. Four plenaries in a row with Working X.
I'm not done yet. All right, cool. Howdy, y'all. So day 2 of UBS, and you finally got your welcome to Texas. Howdy, y'all. My name's Dustin Kirkland. I'm on the Ubuntu server team. I'm your maintainer of the KVM package. KVM is our virtualization technology that we use as the foundation for everything that we're doing in the Ubuntu Enterprise Cloud. The cloud being a platform that we build on top of virtualization inside of Ubuntu. So the key thing that this first part of the presentation is to introduce you, the Ubuntu community, Ubuntu developers, to KVM. Those of you who are not familiar with it, it's an absolutely invaluable tool that I really hope that everyone that comes away from this presentation, if they've not used KVM, can go and play with it immediately, essentially. By show of hands, who's running Lucid already today? Not very many of us. Who's going to upgrade to Lucid by Alpha 1, Alpha 2, or in the Alpha cycle? All right, that's respectable. Who's not going to upgrade to Lucid until at least RC? All right. This is an LTS release, and it's going to be very important that everyone in this room spend some time testing, working, developing, reporting bugs against, just helping us with the LTS cycle. I certainly understand why someone would not be running Lucid today. Actually, Lucid today is really just karmic for the most part, but it's about to change, right? And it can be very disruptive to your daily operation if you're trying to run code that's really intended to break on a daily basis. And for that reason, virtualization is an absolutely beautiful thing. You can keep a stable system running on your pristine laptop and do all sorts of crazy, heinous things inside of virtual machines. So there's going to be a second part of this talk. If you already know virtualization, bear with me today. Or you already know KVM, bear with me today. But I want to introduce the people who've not seen KVM or not seen virtualization, what to do with it, or what can be done with it. I want to show you that. The first thing to note is that KVM specifically requires support in your CPU. It's called Virtualization Technology, VT. You can check that by looking at your proc CPU info. You're looking for either SVM or VMX, depending upon if you're on Intel or AMD-based hardware. If you run the KVM-OK utility, it's a little thing that we wrote to make it easy to do that grep for you, basically. The survey we ran last month said that about 80% of Ubuntu users have VT on at least one of their primary systems. That's an overwhelming percentage of people who can be using KVM. In that same survey, we found that only about 23% of the same respondents actually used KVM. And that's something that I'm hoping to start fixing by introducing you, the developers of Ubuntu, to KVM. VirtualBox is worth mentioning. It came in actually first, and that virtualization technology was being used the most. The advantage that VirtualBox has over KVM right now is that KVM does require the CPU support. VirtualBox actually works well on systems that don't have VT. It's also got a bit more of a graphic interface. I'm not really getting into the graphic interface today. The main thing that I want to show you, if you've not seen KVM, I've written a wrapper script and packaged it in a PTA for Hardy through Karmic, and should be uploaded to Karmic very soon, called Test Drive. The Test Drive project in Launchpad is a real simple project that does two things. The first thing is it remotely retrieves an ISO using rsync or zsync or wget in that order, depending upon what's available. You pass it an ISO, a URL to an ISO, and it will immediately sync that and launch it in a virtual machine. Preferably KVM, but if you don't have KVM installed, we'll try to use VirtualBox. I'm going to show you that right here. I've already got a configuration file, my .rc file. Says that it's just going to do the right thing. So I'm going to launch this in the background. Take a look at what happened here. First, my CPU does support KVM and dev KVM. Oh, sure. All right, let's cancel that and try again. All right, cool. Enter, enter. So back over here, I can see that my CPU supports KVM. I've got KVM. Acceleration can be used. It's going to use KVM to launch this virtual machine. So by default, I'm syncing actually the Lucid desktop AMD ISO using rsync. I actually had a copy cached, so this rsync happened basically instantaneously. If I do this on a daily basis and that daily ISO is changing, it's just going to download the incremental changes using rsync. It creates a disk image. Everything right now is stored in a .cache test drive directory. This is just going to be a sparse QCOW to QCOW is a sparse image. So I'm creating an image that will grow up to 6 gigs, but it's only going to take a couple of K on disk if I don't actually use it for anything, but it'll grow as I install the system. And then it says running the virtual machine. So over here, this is KVM now booting that live ISO, which should have taken roughly 60 seconds or so on this laptop. But as you can see, this is today's Lucid ISO. I think Colin and the Foundations team started producing these, a day or two ago now. But yeah, so this is welcome to Lucid. Development branch. This is pretty cool. This is an easy way that absolutely anyone can do ISO testing. I'm sure that the QA team would appreciate help and assistance from anyone in the community to run through the barrage of ISOs that we need to test at every single milestone. To show enough, so I'm going to kill this off. It's going to tell me that I might want to clean up this cache directory. Basically, there's going to be a stack of ISOs and images that are located in there. What's going on here? Oh, sorry about that. So the other thing that we can do is we can test drive a particular URL. So using just a web browser here, I'm looking at the cdimage.conference, the local repository. I can just pick a random image here, grab the URL, which is going to be an HTTP URL, and if I test drive -u, the HTTP URL is going to use dsync to go and retrieve that image. Rick Spencer is using Quickly, of course, to produce a GTK plugin for this, which is going to be much nicer than trying to launch this from the command line. And the interface will look something like applications, system tools, test drive and Ubuntu ISO, and upon clicking on that, being presented with a list of the Ubuntu, Kubuntu, Notebook, Remix, all the different ISOs that would be out there that need to be tested and certified. So it's something that you can do individually, incrementally, on a daily basis, at the milestones. The key thing is that we really need people looking at testing and playing with Lucid well ahead of RC and beta, and as early as possible in the alpha process. So I'm not sure what's going on here. Sorry about that. Which one? In any case, what we're going to get into a little bit deeper into KVM is going to be the more advanced configurations, the things that we can do with KVM, passing multiple CPUs, different amounts of RAM, disk, to the virtual machines, using AppArmor to confine virtual machines, bridging, and so forth. This plenary was scheduled for 2 days from now, so it was moved back up to here a few minutes ago. George, can we take a few questions?
Yeah, absolutely.
So you've made it very easy to get the brand new version, and people I know are working on making it very, very easy to report bugs. Is this going to be tied together so that the releases have, hey, we found a problem, and it goes straight through?
So I talked to Ara actually about the ISO QA testing wiki and so forth. It would be really easy to publish instructions on how to use this to launch the testing of an ISO. The one caveat that I forgot to mention is that this doesn't really help with hardware compatibility testing, right? This isn't going to be able to test drivers for your hardware, but everything else, interfaces, UIs, colors, package upgrade testing, that's something that we're going to need to do a whole lot of, upgrading from Party all the way jumping all LTSs to Lucid. Being able to do that entirely in a virtual machine in a way that doesn't affect anything else. Also an interface for talking directly to the cloud. A lot of this can be done rather than on your hardware using KVM or VirtualBox, but using UVC or EC2, you can do this in the cloud.
Hello. You said you wanted to improve the UI. Does it mean improving Vert Manager, or is it just custom UI you want to develop?
Right. So Vert Manager is, that's in the, I was going to take that in a more advanced talk on Thursday. Vert Manager is a graphical interface for managing multiple virtual machines. And it uses a layer called libvirt, where libvirt is what actually talks to the virtual machines and does things like dynamic block storage attached. Adding a disk to a running virtual machine, and it just pops up like when you insert a USB key into a laptop or something like that. So that's Vert Manager. This is not a replacement for Vert Manager. This is this is just an easy way of launching a virtual machine, launching an ISO to do some testing. And we've also got VM Builder, which is a good way of creating virtual machines that then become the virtual machine that you work on or deploy or move around or do something else like that. Jonathan?
So what about testing, not just an ISO, but maybe like an ISO with like a couple of extra packages from the PPA that might be still out or something like that?
Testing an ISO and then adding a couple of packages? Yeah. Right, so from that ISO that I launched, I could have installed to that sparse disk, rebooted ad nauseum, added PPAs, modified the packages, done some development, copied that information off of that virtual machine. That's how, until I upgrade my laptop to Lucid, I'm going to develop in virtual machines.
No, but I'm going to go way around.
Okay.
Taking something someone else has developed and then testing it on the machine, on one of the.
You also do --PPA :blah.
Yeah.
Sounds like a wish list feature.
For what it's worth, during the Lucid cycle, we'll be publishing both, well, definitely server images and hopefully desktop images to EC2, possibly UEC-ish, but that you could, fire up an EC2 instance and run add the PBA and get the test done that you want there without downloading anything.
Yeah, well, we have a graphical VM builder. Click for the packages you want and the PBAs you want. KVM image generator.
I don't think there's any plans for a graphical front end to VM builder. VM builder's Snore. I'll yield to Snore on that one.
I think we'll get both graphical and web front ends in due course. I'm not sure that will happen in Lucid.
Did you say that again, Mark?
I think we'll get both graphical and web front ends, but I'm not sure that will happen in Lucid.
Okay. And the graphical front end that we'll have here will be the GTK launcher. Actually, Rick has written that code. The GTK launcher for choose your ISO, click here, it'll sync it incrementally with what you have already cached, and then throw it up in a VM, and you do what you want with it, throw it away when you're done. Right. Yeah. This isn't meant to be anything permanent. This is meant to test the daily ISO in a virtual machine.
Okay, time. Thanks.
Thanks, everyone.